My name is Tom Quinlan and I'm a sales engineer for Norman. Today we're going to be looking at Malware Analyzer G2 version 2. I'm going to start the demonstration by examining the remote API documentation for the product. The remote API is a significant differentiator for Malware Analyzer G2 in that it allows you to interact with the device without having to go through the web user interface or web UI. The API documentation shows that the API is a RESTful API and responses are given in either JSON or Google Protocol buffer format. I'm going to scroll down through the API documentation and we're going to issue a sample API command to start the demonstration. It may not be immediately obvious why I will start the demonstration with this particular command, but it will become more so as I go through. So I'm going to go scroll through the documentation, which you can see has examples, and I am going to select the system section as I scroll through here. Once we get past the samples section, we'll see that we come to our system section, and the command that I'm going to issue in this case is that for the event schema. So I'm going to pull up my command line, demonstrate that you can interact with the API through the command line, although of course you can do it in various other ways through the browser if you choose, or the programming language of your choice. But for right now, I'm going to issue a curl command using the -k flag. The -k flag in this case is for the SSL certificate because the demonstration box I'm using has a self-signed certificate. But when I issue the command, I'm going to select the server to which I want to issue it, which again is the demonstration box. Going to select the remote API. In this case, again, I'm going to use the system section and then the event schema. And when I do that, it will return the results in JSON format. I have 45 results here, and each of these results corresponds to how information is stored in the database with respect to malware behavior. If we look at these, each one starts with a 2 or 3 letter code, such as FS for file system here under FS create. If we scroll down a little further, we have things like IP or Internet Protocol for networking events. Scrolling down further still gives us other ones such as OBJ for object creation events. And then at the bottom we have REG for registry, as well as SBX for sandbox and SYS for system. So you can see that our event schema has been returned in JSON format, and we'll be able to use the event schema as we go further through this demonstration. What I'm going to do for the rest of the demonstration is I'm going to use the web user interface, so I'm going to select that now, and I'm going to log in, which is how most people will start using the product. When we get into the actual device, the first thing that we see is our start screen. In this case, I have my most recent samples here on the left. I have the ability to drag and drop files for analysis in the IntelliVM in the middle, as well as the ability to do quick searching here on the right. At the bottom, we have our System Information tab. The System Information tab gives us the current queue status, as well as the queue status for the last 24 hours, and storage information for the database and operating system. Additionally, here in the upper left, we have our available processors, which consist of 2 sandboxes, and 5 IntelliVMs or intelligent virtual machines. Malware Analyzer G2 has 2 technologies for automated dynamic malware analysis. The first is the Norman Sandbox, the Norman Sandbox being an emulated environment in which we are emulating the hard drive, RAM, and network of a machine. This allows us to be a little bit more interactive when we process malware. We can emulate responses to the malware, so if malware asks for a particular IP address, we can provide a dummy response to see how the malware behaves. The IntelliVM is an actual virtual machine running in VirtualBox. It runs Windows XP Service Pack 3 with Internet Explorer 6 and Adobe Acrobat 8 by default. The IntelliVM can be customized, which I will cover in additional detail later. Typically, to start, we will go to the Analysis Center. Once in the Analysis Center, we can see again that we have the ability to submit samples and to view our current samples. And I'm going to submit a sample which can be either a file or a URL. I'm going to start with a file in this case. So clicking the Submit Samples tab brings me to the Add Files dialog box. When I click Add Files, I can select one, and I'm going to select a file from my malware directory. I'm going to select a variant of SpyEye, which has the hash and label of 82827 ending in 91A here. So we can see that the file is uploaded. When we select Continue, we have the opportunity to select which of the two technologies, or both, that we want to submit the file to. You can submit it to the sandbox or to the IntelliVM. In each case, we have the ability to do a summary capture, a detailed capture, or a custom capture. A summary capture will give you the most relevant information with respect to the particular sample's behavior. A detailed capture is exactly that and will give you all of the information with respect to the behavior of that particular sample. And then a custom capture allows you to change settings for each or both of the technologies. We started the demonstration with the event schema because some of these custom settings depend on knowing the event schema. So for instance, we can filter based on registry events, REG, or filter based on file system events, FS, or based on sandbox events here as well. In the sandbox, you can also get a PE dump or a memory dump, and you can change each of these, but for now I'm going to do a summary capture for the sandbox. We do have custom captures available in the IntelliVM as well. If we look at the custom settings, we can see that again, some of them are filters based on the event schema. And additionally, we have IVM specific settings, which would be things like IVM timeout. Typically, we run samples for 60 seconds by default in the intelligent virtual machine, but you can change that if you want to be shorter or longer. IVM firewall can be changed. We have 3 customizable firewalls installed by default, but you can add your own or select which one you want to use here. And then finally, IVM get drop files allows you to actually get files that malware may create or download for analysis later. I am going to do a summary capture in the IVM as well though, in this case, and I'm going to select Create Tasks now. Once that is done, we are brought to our sample details page. And you can see here on the left that our label matches the MD5 hash of this particular sample. And on the right hand side we have our tasks. We have our task in the sandbox as well as our task in the IVM. The task in the sandbox finished in 2.25 seconds, which tells me that in this case this particular sample did not run correctly in the sandbox. And as we can see here, it didn't. That's okay. The reason that we have the two technologies is that they complement each other, and not every sample is going to run in both technologies. For that matter, not every sample is going to run all the time. We do not claim to be able to capture 100% of the samples. However, we do use the two technologies to complement so that we can get higher results. Here we can see that this particular sample was looking for a particular path string for comparison, which it did not find, and so it stopped running. If we go back, however, this particular sample will process in the IntelliVM. What I'm going to do is, rather than wait the 60 seconds in this case, I'm going to select my samples and go to the last page here where I have already run this particular sample. You can see that I'm looking at a variant of SpyEye, as I mentioned, and that the label contains the hash, which is the same, so that you know that I'm looking at the same sample. If we look at the results in the intelligent virtual machine, we can see that this particular sample does run successfully and we do get an analysis. The analysis is the form of a task report. And the task report starts in the upper left with our risk level, which in this case is 8. The risk level goes from 0 to 10, with 10 being the most malicious. The risk level is a maximum of the risk scores associated with the various patterns of behavior. The patterns are run against the actual activity of the sample. In this case, we can see that we have our process and threat events, we have our named object events, file system events, network events, and registry events. And these will also correspond to the event schema with which we started the demonstration. Here we can see that certain activities are highlighted in red, and these will correspond to particular patterns on the left. If we click the patterns, we can see which activity corresponds to that particular pattern. So in this case, we have this variant of SpyEye creating a well-known mutex for which we already have a pattern. Down here in our network events, we can see that this particular Malware sample attempts to connect to a Russian website called billiardniy.ru, as well as this particular IP address over port 3444. But if we wish to examine the patterns, we can go ahead and do that. We see here that we have our SpyEye mutex pattern matching this particular behavior. And pattern matching is a very strong way of being able to determine whether a file is malicious or not without having to resort to signatures. Malware has to do certain things in order to get onto or stay on a particular box. And that will always be present in the activities that it displays. If we look at the patterns that we have installed on this box, we can examine the patterns and we can configure them too. In this case, there are 159 entries for patterns. This box has a few extra as it's a demonstration box, but typically it's 150. Here we can see that these patterns correspond to actual behaviors that malware is likely to exhibit. Creates thread in Windows processes, for instance, writes to Windows process, rogue antivirus. Checking for a debugger is a well-known activity of malware. And if we look at the patterns in question, we can see that we do have generic ones that match large amounts of behavior across malware samples, but then we also have specific ones, such as the SpyEye mutex pattern one. In this case, we can see that this particular pattern has a risk score of 8. The risk score of 8 in this case, being the maximum, is what set the overall risk level that we saw earlier. These patterns can be configured. The pattern configuration is based on the event schema with which I started the demonstration. So if I wanted to add a pattern here, I could go ahead and do that. If I add a pattern, I can choose based on the event schema which of the various pieces that I want to look at. And in this case, I'm going to select IP Connect. I'm going to hit Save. And then now that I have an IP Connect, I can go ahead and add a sub-pattern to that. Once I choose my sub-pattern, I have options here that are specific to the previous pattern that I chose. So here we have local address, local port, protocol, etc. All of these are specific to IP Connect. Had I chosen something else, these would be different. But let's say I choose local address here. The very powerful part of this is actually our operators. Here we have logic operators that can be very broad or very specific. They include things like regular expressions. So if I wanted to select a local address that matched pretty much any dotted quad notation, for instance, I could do pound, 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 slash dot, and then repeat this several times. And then we could very quickly have a pattern that would match dotted quad notation. However, if I wanted to be more specific than that, I could select equals and choose 10.0.1.17. So you can see that using the logic operators, we have the ability to be very broad or very specific in what we're looking for. And you can change the existing patterns as we've provided. So if I undo the changes that I just made, I can actually change this particular pattern as it came installed. Let's say I want to redefine the SpyEye mutex pattern. You'll see that I only get handle and name for object mutex creation. I can change this using the logic operators to a regular expression and say, let's have a SpyEye mutex pattern that starts with any 2 characters. I can now do that using the dot grep expression. However, I'm going to leave this as it was because it works very well. Select cancel, but you can change the patterns that we have or you can create your own. And if we go back to the task report, we can continue to look at the task report to find what it is that this particular sample does. We see our patterns here on the left, as well as the activity on the right. Below that we have our sample details page. This is largely a repeat of the previous page, but it's helpful to not have to go back. Below that we have our virus total link. Virus total is an optional feature that can be installed in the Malware Analyzer G2. And if it is installed using the end user's own public API key, you can select it to get a report on the right-hand side of which antivirus vendors also detect this sample. In this case, it's 39 out of 42, and the report shows you which ones do. If we close this, we can continue down the left-hand side. We have a packet capture file from this particular sample. We are listening to the network card of the virtual machine in promiscuous mode, and the packet capture information is created as a PCAP, but the information is also stored in the database, which I'll show you in just a second. Additionally, the packet capture information will change based on the behavior of the malware. Since we do have customizable firewalls, whether or not the sample can communicate out will determine what is present in the packet capture. We also have an event distribution chart, which gives us a good idea of what a particular sample is doing in the time that it runs. In this case, about 30% of the time, this particular sample is attempting to send information out. If we continue to the top again, we can see that this information is available as a downloadable PDF report. So if you click on that link, you can then send a PDF report of this information to a third party without having to give them access to the malware analyzer if you choose not to. This information is the same information that we've seen in the summary capture, and had we done a detailed capture, this report would be significantly longer. If we continue, we can view the full event list for the various captures that we've done. Since we've done a summary capture in this case, we can view the full event list of the summary capture. When we click on that, we do get a list from the database of the behaviors exhibited by the malware. This can be filtered in real time. So for instance, if I want to filter based on the event schema using the file system notation, I can select FS. And now instead of 126 entries, I have 6. If I want to see those entries where file system was read or written for an executable, I can type the executable header string of MZ, and now I can see that I have only 2 entries. In this case, we can drill down into each entry and we can actually see the data as it's stored in the database. And we can see that this is indeed an executable with the MZ header string here, and that this is also packed using UPX. I mentioned earlier that we could also obtain networking information in the database, and that's the case. If I use the IP string based on the event schema again, we can see that the networking events are actually displayed here, so I don't have to download the packet capture if I choose not to. All of this information was exhibited by the malware itself. It did attempt to connect to this particular address and this particular IP address. But of course, since I did not allow the malware to communicate out, I selected the firewall. The information here is only what the particular sample attempted to send, and no further information was available. But I could change the firewall if I so chose. I'm going to select the administration tab so that we can look at the firewalls now. When I look at the administration tab, I have the ability to change many of the things associated with this particular malware analyzer instance, and the first thing is the firewalls. We do have 3 firewalls that ship with the box by default. The first is the isolated firewall, the next is the limited, and the last is the unlimited. You'll see that unlimited is default on URL submission, because if you're loading a URL for analysis, we obviously want to be able to load that. But isolated is the default for malware analysis. If we look at the firewalls, they can be changed. You can change the ones that we provide or create your own. This is very similar to just about any firewall configuration. And in this case, what we're doing is dropping all traffic with the isolated firewall. The limited firewall drops Windows file sharing and SMTP, but allows all other traffic. And then of course the unlimited firewall allows traffic overall. In addition to changing the firewalls, you have the ability to create users. You can manage users with that particular tab, and if you create a new user, you have the opportunity to set an access level for the user, the difference being that admin users can create other users. And then you can set a logical separation in the UI where a user can access all the data or only their own. This does not extend to the API at the moment, so this is a logical separation in the UI. I mentioned the virus total integration when we looked through the task report earlier. The virus total integration requires that you have a public API key. The networking can be set up so that you can use DHCP or a static IP address, and you can also set an internet dirty line setting here if you choose to have a third-party connection on which to allow malware to communicate. Restart and shutdown is pretty straightforward. It does that for the appliance. The license is where you install your license file. And then the Customize IntelliVM tab is the tab where you can customize the intelligent virtual machine. Earlier I showed the System tab and mentioned that we have 2 sandboxes and 5 IntelliVMs. These 5 IntelliVMs consist of 1 main virtual machine that is then snapshotted 4 additional times for parallel processing. When you wish to customize the IntelliVM, and you can customize the IntelliVM in any way you can customize any installation of Windows XP3, you enter maintenance mode, which I won't do on this demonstration box. But when you enter maintenance mode, the virtual machine is brought up in a way that you can connect to it over RDP, the 4 snapshots having been destroyed already. Once you have then installed software into the IVM, you would exit maintenance mode, and then the machine is brought back into a state for processing, and the additional snapshots are then again created. You can install any type of software into the virtual machine. The first thing that most people install is Office. The virtual machine can execute any software for which supporting software is installed. So by default, as it does not have Office installed, it does not handle Office files, but once you install Office into it, it then becomes capable of analyzing documents, Excel spreadsheets, etc. And this is handled under the IntelliVM customization tab. Additionally, we have the ability to extend the virtual machine with plugins. If we go back to our GitHub repository, we can see that we do have an IVM plugins directory. The IVM plugins directory currently stores the Norman plugins. These plugins are written in Python. We have a memory dump plugin which works similarly to the sandbox PE dump, so now we can do memory dumps in the IVM. But additionally, we have other ones that are more specific, such as the spyi.py file, which is the spyi plugin, and that's the reason that I chose that particular sample for this demonstration. You can see that although you can interact with the API via various methods, plugins do have to be written in Python. And if we look at a sample of spyi where we've run the plugin, we can actually see that we can get further information that wasn't available through the dynamic analysis that came by default. Spyi is a banking Trojan, and one of the more nefarious tricks that it uses is that it uses configuration information that it only writes to the machine's RAM. Since a dynamic analysis platform is limited in its ability to only look at file system information, information written into the machine's RAM would not be immediately available. However, using the plugin architecture with the Malware Analyzer G2, we are able to extend the dynamic analysis portion of the product with the ability to do some of the more forensic or static analysis capabilities. And in this case, the spyi plugin will actually go into the virtual machine's RAM and get the configuration files out that this particular variant of spyi uses. If we look at a task report where we've run the spyi plugin, we can see that much of it is very similar, except that when we get to the PCAP section below there, we have an Other Resources section. We've made available the various pieces of configuration that this particular sample uses. We can see that we have a version.txt, we have a password.txt, and then we have a zip file. This zip file is the password protected zip file, which the configuration information is stored, and here we have the password. I have already downloaded these files, and I'm going to go to my Finder, and I am going to show you that you can get this information out to further figure out what a particular sample is doing. In this case, I have the version.txt, which is 10348. Additionally, I have the password, and if I double click on the password.txt, I can select the password, and copy it, and then close the file, go back to my Finder, and then I can actually open the zip file. And when I open the zip file, I will be prompted for a password. If I paste the password in and hit continue, I can go back to the Finder and see that now I have a folder that represents the unzipped contents of this particular zip file. Here we have some additional files that we didn't have before. The first is the collectors.txt, and if we look at that, we can see that this information in particular is not new because it matches information that we received from the dynamic analysis, in this case the 83 IP address over port 3444. However, if we continue through those files, we have a config.dat file, custom connector.dll file, which we can then analyze in mag2. More importantly, we have a custom connector DLL configuration file. When we double click on this to open it, we can see that in the first case, the billiardniy.ru address is already known to us. However, we do get 3 additional command and control addresses which we didn't previously know about, to include tennisniy.ru, intsys.net, and irfcis.net. So now we've been able to take the dynamic analysis portion and extend it with the forensic analysis, in this case, to be able to determine additional command and control addresses that we might not have otherwise gotten. If I want to then take this information and use it further, I'm seeing here that these particular domains all include .ru for Russian. And what I'm going to do is I'm going to go back to my start page, and I'm going to see what other samples use the .ru domain. If I hit search, I can select the ability to search based on certain criteria. In this case, I'm going to select event data. I am going to select IP name resolve, again based on the event schema. In this case, I'm going to select name because that's my only choice. And I'm going to do contains.ru. And we'll get a result set that is dependent on what malware we have in this particular appliance. And we can see here that we have several sites that connect to Russian websites and several URLs. And of course, we can submit URLs as well as samples. But we get 442 non-unique entries for the .ru string in our malware database on this particular appliance. If I select Submit URLs, I have the opportunity to submit a URL. And if I were to do billiardniy.ru, I could submit this as a URL in much the same way I could submit a file. And when I select Add URLs, I have the opportunity to submit it to the IntelliVM for, again, summary, detailed, or custom capture, and I'm going to select Summary and create the task. When I do create the task, it processes it in the IntelliVM, but again, I can go to my samples and I can show a demonstration of what a particular URL would look like. In this case, we have www.3322.org, which I have previously submitted, which is already run. For this particular instance, we see that this is considered a malicious URL with a risk score of 7, risk level of 7. That's because the pattern it matches is connecting to a Chinese dynamic DNS. And although it does not actually load anything, as we can see in this screenshot, screenshots not being unique to URL analysis, but will pop up for any screen that is created during an analysis of either a URL or a file. Even though nothing is loaded, we can still see that by examining the behavior of the particular URL being loaded in the IBM, we can still get a good idea of whether or not this particular site is malicious. This concludes the demonstration that I have for you today, and I encourage you to get in touch with someone at Norman if you find this to be an interesting and useful product. Thank you very much.